Yeah, hello everyone. This is Recursion from PTS setting. I will wait for a couple more minutes for others to join. Yeah, hello again. Yeah, for your question, Shireen, amortized complexity, right? Okay.
Yes, sir. Actually, I think we were introduced to this concept in the lectures in week 3 or 4,
Yeah,
but it is not uh, very clear to me. But we need it again in week 9 of DBMS.
okay. 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 Can you see the screen now? Yeah, very good.
Yes, sir.
Okay. Let's say let's say a list. Okay. We have some elements. Let's say you are doing some operation which takes order of n. I mean, let's say if you are doing some operation in this list, I mean, the first inner list, that will take order of n. Okay. You are doing the same operation in second list, that's the same operation. So it will be also order of n with respect to this cell, number of elements within the list. Similarly here as well. But if you see that overall operation, right? I mean, it is a fixer that you are going through that total number of elements within the list of list. Let's say if you unravel the list into a single list, I mean a simpler one list, it will be like a 1, 2, 3, 4. It is I'm saying the length of this list. the total number of iteration or the number of operation you are doing, right? That will be some number. Okay. So what you do is you can choose, I mean, you can take the average case of it. That is totally possible. Then you can say amortized cost of log n or like that.
So in this case, amortized cost will be
Okay.
still O of n.
Yeah, or
Okay.
yeah, it's simply like a seems like average, but it is totally fixed. It never crosses over that bound.
Okay, sir.
Yeah, with an example, if I'm saying, then let's say adjacency list. The similarly, let's say that node 0 have like that, 1 have 4 and 5, 2 have nothing, 3 have 4. Let's say it's a directed graph like that. 4 has 5, 5 have nothing. If you consider here that if you are doing operation, any operation, right, then the number of okay, let's say a simple offering, you are taking every element which is linked to a node I. Okay, then you are picking every element in this list, a simple operation. Then overall, how many number of times you done the operation is the number of edges which you have. I mean, like 1, 2, 3. Here it's 3. Here it's 2. Here it's 0. Here it's 1. So it's 3, 2, 0, 1, 1, 0. It will be 7, which is totally equal to the I mean number of edges here. So you can say the amortized cost was I mean, which is equal to number of edges here. I mean, it's the cumulatively. But if you are specifying individually, which is not appropriate. Whenever you are saying amortized cost, you are doing the operation for the whole dictionary in the entire set.
Okay. Okay.
Let's say
Got it.
yeah, okay. If you are doing only this operation, right, only for the node 0, then we cannot assume it's a amortized cost. That's the only difference.
Okay. Understood, sir. Thank you.
Okay. Okay. Anything else? Others? Okay. First of all, I want to ask you, how was this to everyone? Just want to get your feedback. Any doubts there? Yeah, pretty good. Anyone?
Yeah, good evening, sir. Am I audible?
Yes, pretty good. Yeah, now we can hear you.
Yeah, sir. Actually, I am facing a lot of problems because the the assignment solutions are being uploaded. Like the PDFs, I'm actually missing those. Uh, is there any possibility you could release them? If not along with the weeks, maybe if you can release them before the quizzes or before the end term exam.
Okay. Yeah. Okay, you are talking about graded objective solution, right?
Objective solutions.
Okay,
Also,
actually, yeah, that won't be released for this time, surely. I mean, it's a course policy. We are not releasing solution for that. But you
yeah,
can always refer and discuss it.
I know that, sir. I actually Omkar sir also mentioned in the discourse forum that it's a course level policy.
Yeah.
But this is the only course for which this policy has been taken. So I actually wanted to know why, like, what was the reason behind this policy? And actually, the PDFs are much helpful, like for revision and all. So that maybe I asked him if he could reconsider the decision, but I haven't gotten a response. Like, no explanation and nothing else.
Okay. Yeah. As far as I know, it is decided on the initial course beginning onwards. It is the decision made on question, because it is the thing which wanted the students to, uh, I mean, get the solution. If you know already the solution, many students are saying that they are looking into the solution and immediately losing interest on solving this problem. It's also from our way, from our side, the students have to try on their own.
Okay, I mean, yeah, that could be a valid reason, but in that case, why not release them before the quiz, like before the final exam, if you can release all of them?
Okay, yeah. Anyway, I'll talk into the respective
Actually,
person. Yeah,
why I am asking this, I understand where the core support team is coming from. I understand that, so like it is encouraging us to work towards the solution ourselves.
yeah.
But having them in PDF form is actually very helpful, especially before the exam for revision. Since the solutions generally contain all the like possible ways to approach a problem, those are actually great for revision. And one more thing is, for example, I am stuck in, for example, question number 3, and then I have to look up discourse. I have to actually search
Yes.
whether others have asked it or not. So that becomes tedious compared to having a PDF. If not now, if not along with the normal release schedule weekly, if possible, kindly release them before the end term.
Okay. Yeah. Anyway, I'll pass this to the respective person, but I cannot guarantee anything. Anyway, I'll pass this to the respective person.
Sure, sir. Thanks. That was a
Yeah.
suggestion, sir.
But what we expect from the student side is, you have to make notes. Whenever a student, you are treated like equal to the IIT students, right?
Yes, sir.
So, yeah, if you know, you cannot, if you are an IT student, you cannot ask the same question if you go to a regular class. Yeah,
Okay, sir. Understood.
yeah, I understood what you are saying, but generally it is a good practice. Keep a note for yourself, a rough note itself. Whatever you are doing rough, right? Maintain a notebook. If
Yes,
you
sir.
if you see during your when you are solving the graded assignment, right? If you simply look back your old notebook, it's much better than the PDF itself.
Yes, sir. That's right. That's correct.
Yeah.
Sir, I just wanted to clarify one more doubt. This policy decision, you say it was taken at the very beginning of the course.
Yeah.
Was it mentioned in the orientation program?
Okay.
Because
That
as
I
far as I remember, it was not mentioned anywhere. Like people asked for it, and then it was announced that it won't be released.
Okay, I'm not sure whether it is announced on orientation program, but orientation program mainly announced the grading policy and how many exams. When those are the main things are announced in orientation program.
Okay, sir. Okay.
Okay. Others, any doubt on week 9, and what about the feedback on quiz?
This Srinivasan here. I haven't completed the week 8 lectures, let alone week 9 lectures. So I don't have
Okay.
any specific doubts. I thought, if there are others who have questions, I thought I would just listen to their discussion. But I haven't read, watched enough of them to have a question.
Okay. Yeah. Anyway, keep your. I think it's Wednesday. I think coming Wednesday, both week 8 and week 9 having the same deadline.
No, week 8 I think is earlier on Sunday,
Okay, so
and I
okay,
think week
I'm not
9 is
sure.
Wednesday.
Yeah. Okay. Okay. Just a heads up. If you are coming into week 9, just understand what is dynamic programming first. Just clear about the concept, then look into the program, then it makes all sense. Just a heads up. Just rewatch the lectures if you haven't understood that enough, or if you haven't understood what is dynamic programming. Then understand it clearly, then look into the problem, then that will resolve most of the doubts when it comes to coming into problems. Yes, please.
I got it. Thank you.
Yeah. Yes, you're muted. Yeah. What's your doubt?
Hello, sir. Am I audible?
Yes, yes, you are audible now.
So I have a doubt in week 8 of closest pair problem.
Okay,
Uh, in that, when we are merging the like by divide and conquer, why are we selecting the 16 box next to it?
okay, yeah. Okay, this one, right? Okay. The thing how it works is we know delta. Delta is the smallest distance between among all every 2 points in this in the Q region of Q. Okay, DQ. So delta is the minimum of both two. So if you are keeping into blocks like that, there is total. We can be totally sure that there is no. I mean, no points between the same blocks. That you have understood, right?
Yes, sir.
Okay. The 16 block thing is just for I mean, you don't want to. I mean, consider as a. I mean, some don't want to based on the number of points here. Okay. It will. I mean, it will make a constant out of it. If we search for each block, compare one block with every other block, the final thing will be a constant number, no matter what. How large is the I mean distance, or how large is the distance between each dot, or like that. It is one of the thing which makes constant out of it. We are not depending on the length or some number of points here or like that.
Okay, sir, but I understand that. But why do we select 16 blocks ahead? I mean, we can do it with just 8. And how do we are dividing them into the bins, the points? If they lie on the boundary, how will we decide where to keep them?
Okay, actually that you can do with like a course level, I mean code level thing. Whether if it's equal, you are moving to right or moving to left, that you can decide that. Even in this case, right? Even the previous case or something, we did the same thing. One of the previous problem also. Also, one more thing, we are considering that no 2 points are on the same x-axis or y-axis. That's also there.
Can you repeat, sir?
Okay. Here, okay. One assumption we took in the beginning. There is no 2 points which have the common exactly same x and y coordinate. Okay. 2 points are the
Okay, every
same x
point is
or y coordinate.
distinct.
Yeah. Then you have to rotate slightly and ensure it shouldn't be problem. I mean, even a small fifth decimal digit, then it works. Yeah. I mean, the 16 points is totally for the. It should not cross the bounds. That's it. 16 blocks. Yeah.
And if we can just compare it with the points in Q segments, I mean Q regions, with just the R regions. I don't think we have already computed the closest points in Q region. So I don't think it's necessary to again compare the blocks in Q region.
Hello, sir.
Yeah, I didn't get the point. Okay, just I'm repeating what you said. You are saying we already computed on Q region and R region. Then you are saying why should we compute on Q? Again, that's what you are saying, right?
Yes, sir. Yes, sir.
Let's say what you are saying is exactly this 2 point. right? I mean, it both belongs to the Q region.
Yes, sir.
Yeah. I mean, that I agree. But I mean, it's the simplest thing. Then you have to eliminate those based on that. I mean, it's just a simplified code. That's all. You can optimize the algorithm even better. I mean, it's one of the simplified form of algorithm.
Okay, so it won't affect the larger means overall complexity will be the same.
Yes, exactly. Yes.
Okay.
Yeah, because
Hello, sir.
yeah. Yes.
Sir, I have a problem in this problem.
Okay.
Can you please explain the problem statement and then step-by-step solution? Actually, this problem get messed up in my mind, and I could not find the step-by-step method.
Okay.
I mean, in simple terms, can you explain this?
Okay, you want to go through the entire thing again. That's what you're saying, right?
Yes, sir. This closest pair point thing.
Okay. Okay. Just I'll go through.
Actually, I do not need. I mean, all the details, but
Yeah.
just the key points only.
Okay. I mean, so far you are clear with one dimension.
Yes, sir. Yes, sir.
Okay.
There is n square because for each point we have to know the all the other points. It is n into n minus 1.
Yeah.
That
Okay.
I have understood.
Okay. First of all, what we are doing is divide and conquer. Okay. So we are dividing the region and solve them independent of other region. Okay, that's the first concept.
Okay.
So even though we are dividing and solving, we are during the time merging those concepts, we are that time we will compare whatever things required, but those division will be combined separately. That okay, that you understood.
Okay, so the delta region comes when we merge the two split regions, right?
Yeah.
Okay, then can you explain the sorting kind thing, that QX, QY, that thing? There are four different components. Yes, sir, this thing.
Yeah. Okay. Actually, there is a point P1, right? Let's say assume it's a tuple of X and Y. X and Y coordinate.
Okay, yes.
X and Y coordinate. Okay. So
yes,
then there are two copies. I mean, two lists. Px is the list of tuples. Let's say that was arranged sorted based on X coordinate.
Okay.
Py is the same whatever the list, but that is sorted based on Y coordinate. That's the difference, but both are the same, but sorted in different order.
Yes, sir. This I got it.
Okay. So now for then whatever the points, right, we are splitting into two half by inserting a vertical line in between. Then we have to move. I mean, then we have to split into Q and R. We are finding the point which is very nearest to the vertical line.
Okay, so what I'm getting is we have to split all the points in the basis of X coordinate.
Yeah, first X coordinate.
Right. The splitting will be according to X coordinate, and the sorting is based on both X and Y coordinate. Is it?
Oh, okay. Just one second. I'm saying. Okay. You are inserted a vertical line, right? This R belongs to QX. I mean, this first graph will be a QX, second graph will be RX. Then you have to split it accordingly on vertical angles.
Yes.
Okay. Those
based on X coordinate.
Yeah, that splitting is based on X coordinate. Let's say we have to find the smallest coordinate in our smallest X coordinate. That will be that's nearest to the vertical line we are splitting. I mean, in this example, this point.
Yes.
Okay.
Yes, sir.
I mean, all the points which is in PY. I mean, the entire points which have the Y coordinate system. Okay. If the X coordinate of P is less than XR, we are moving to QY. moving that point to qy, or else we are moving into ry even though it is equal.
Okay, can you repeat this part?
Okay, let's say I'm explaining with an example. Let's say I taking all the points in py, which is ordered by sorted in y coordinate. Okay, this point.
Yes, sir.
So let's say I've started from, let's say my coordinates are like that, assume. Then I'm started in ascending order. Then the first point I will take is this one. Okay.
Yes.
Then I
Yes.
take whether it is less than x or that x coordinate. So it is greater than x, surely. The x coordinate is greater than the xr coordinate. It is xr.
Yes, it's greater than the middle one.
Then I am moving to ry. Then it will go to ry. Then I am taking, let's say I'm taking this point, then it is also greater than r, it will move to r1. Let's say after this, it is the next point. I'm taking that, it is less than xr, then it will go to qy.
Okay, okay. So first we are sorting according to x and according to y.
Yeah.
Then we split based on x coordinate.
Yes.
And it is become partitioned in R, Q and R.
Yeah.
Okay. Now we are select. What is the next step? We are selecting based on y coordinate, right?
Yeah.
Okay. The points whose x coordinate are less than the middle line, that will be in Q.
Yeah.
Okay. Okay.
You got it right. It is the total splitting process.
Okay. If x coordinate of p less than xr, so xr means what thing?
Yeah, xr is the point, which is the smallest x coordinate in r. R is this region.
Okay. How could I know the middle line coordinate?
You have to, I mean, splitting, you are inserting a half. I mean, let's say, I mean, simply take this point. Okay. I mean, take the further last point.
Yes, sir. Suppose we are taking a point, how could I know that it will be in Q or in R?
Okay. Okay, that doesn't initially that for this process, right? This process that doesn't matter.
Okay.
Okay. For this process, whatever the x coordinate, this line have some value, right? Some x equal to some value, some unit, let's say 5 units or like that. Okay. If you see any point which is less than 5, yeah, that will be before this point. It is all go to qx, the first first part of px. This thing we can directly compute it from the px list.
Yes.
That next the second half, right? That will go to rx.
Rx, yes.
Yeah.
Up to this, it is clear.
Yeah. Yeah. Okay. So far, what we have did is only for qx, rx. We know. Still, I want to find qy and ry.
Yes.
I know this. Then I don't know qy. I don't know ry.
Yes.
Okay.
Yes, sir.
Okay. That is the splitting region here. For you have to find the coordinate. I mean, you already know rx. Okay. Let's say if it's order on ascending order, the first value, right? First point is the xr.
Qx is first step of px. Okay.
Yeah. Also, one more thing we have to know, whatever which is in px and py, right, which is already in a sorted order. So whatever we are taking from one by one, which is also just implicitly will come in a sorted order only, naturally.
Sorted order. Yes.
Okay. If you take the first element in rx, that will be a xr.
Okay, so we do not know the middle line coordinate, so we assume that the first point in R, that is the middle coordinate.
Yeah.
Is it?
Yeah.
Okay.
Always know, see that whenever you are saying px, right, just to understand px, it will start from x one, it will be the 0th one. Let's say it is the second one coming from left side, it is the third one, it's fourth, like that. But
Yes.
if you are saying it is based on px, but py, it will be like 0 1 2 3, here it will be 4, like that.
Yes. Yes.
Okay.
Yes. How to get the QY and RY thing?
Yeah, that's the thing. For qy and ry, you have to find the first xr, this point. I mean, this diagram, this point, which is
Yes.
which is closest to the that vertical splitter line.
Yes.
Okay.
Okay, sir.
Now we are taking every points in py, which is already in a sorted order.
So in sorted order according to Y.
Yeah, according to y. So it will come in this it will come here to based on this coordinate. Say it will be it will be the first 0th element, first element, second element. But here for this element, I am comparing the x value, x coordinate of that point.
Okay. Okay. Yes. X coordinate of that point.
Then we are moving accordingly, whether on qy or ry.
Okay. Yes, sir. Now I got this QX, QY, RX, and RY. But one question I had, that why we need both X sorting and Y sorting? Mm, I mean, how it will required in later?
Okay, I am saying, yeah. Okay, it is done recursively. Okay.
Yes.
Okay. What you have come with, you are coming with px and py.
Yes.
Okay. So you are splitting that into two region. For that, one region is q, another region is r. Okay. For that, then you are entering totally into this region. If you wrote that function, that will seems like a px py. Then you have to do the splitting.
Yes, I
Yeah,
understood that PX is the
that's
sorted by
why.
X coordinate, and PY
No,
is by Y coordinate. Now, why I need both sorting using X coordinate and Y coordinate? I
yeah,
mean,
that's what I'm saying.
why X
Okay.
coordinate is not enough?
Okay. Yeah, then x coordinate is not enough means, let's say, okay, I'll give you an example.
Yes, yes, sir. Yes, sir.
Just consider these 2 points. If you started these 2 points, right, it is much nearer to the point than some other point. Okay, like coordinate. Okay, some other point. Okay.
Yes, sir.
If you see, consider 2 points, which is you are considering only the x coordinate value. Then you cannot differentiate based on the y coordinate value.
Yes, actually, if we sort by X coordinate, then we can detect that these all 3 points are in R component.
Okay, if you have only x coordinate, then that will seems like a 1D problem.
Okay, okay, that seems like a one problem.
Yeah.
Yes, that I'm not able to visualize that why we need the
Okay.
Y sorting.
Okay, let's say this is some x, which is
X
if you
X sorting is kind of trivial one. This I can visualize, but the Y sorting I cannot visualize that why we need
yeah.
it.
Okay, I'll say okay. This to consider this 2 point. It is clear that these two are the nearby one, right? These are the closest point
Yes.
among these three. Okay.
Yes.
But if you consider only x sorting, the value of x coordinate of this point, which is in the middle of these 2 points. But if you sorted only on based on x coordinate, then you will get these 2 points or either these 2 points, which is totally a wrong value.
Okay. Now I got it, sir. Thank you, sir.
Oh.
Now I got it. That the vertical separation, that is done by Y sorting.
Yeah.
Right. Okay, sir. Now, could you explain the merging process? The splitting is clear.
Okay. Okay. Now the combining thing. Okay. Whatever you do on splitting, right? In the splitted region, dq represents the smallest distance between any 2 points.
Okay.
Okay. Which
Yes.
is in the region Q. Similarly, on region R, dr is the region. Dr is the smallest distance between any 2 points.
Yes. Yes, sir.
Okay. So whatever we did is with respect to this region only. With respect to this region, but there could be 2 points which is much closest to this one, this splitted point. That could be possible that will be the smallest distance
Closest,
between
yeah.
any 2 points, then dq and dr.
Yes.
So far what we have is we already have the smallest distance between 2 points on the one region, this region. So what we lack is this borderline region. I mean, we don't want to compare all those things, because we already know that the smallest distance between these 2 points is dq and dr. Okay, so we can somewhere search in this some respective boundary. That's enough.
Yes.
Okay.
Okay, sir. The
That-
minimum will be delta between dq and dr.
Yeah. So we are taking the delta, which is minimum among dq and dr.
Yes.
So we can definitely say we can on the left side of dq, left side of q region, on the right side of the r region, that 2r region is enough. We can totally show no point will be have which cannot be more than this point, more than this region.
Yes. Outside this region,
Yeah,
those
even
are
if you say,
better than.
yeah, even if you say this region, right, or this
Yes.
region, that won't be possible, which is already greater than delta. If that is the case, that will be incorporated here also.
Yes.
Which is
clear.
not required for us. Even this 2
Yes,
point, which is surely greater than delta, which is not our focus.
Yes, sir. It is clear, but then I'm not getting that. Why we need the grid-like thing?
Okay. Grid-like thing is just only for okay. Even this delta, right? You understood this concept. Let's say,
Yes.
why you need to compare this point to this point, even though the delta region was like the delta distance was like this much only.
Okay.
You understood point?
Yes.
The delta distance was like it is the delta distance, but why you need to compare this point to that point? Somewhere, if some point is here, that is the reason why we are splitting into 16 parts, or whatever the parts required.
Okay.
Okay. One more thing you have to be clear. We are not splitting the entire thing into exactly 16 or like that. That is based on the delta part.
Okay. So after certain number of grids, we will not compute the. We will not compare.
Yeah, exactly.
The distance.
Yeah, if your focus was this in this point, right, then that region will be like that, somewhere like it is the region. It is the only region you are searching for.
Okay. Yes.
So if you are going into the next point, that region will vary.
Yes.
Yeah.
Yes.
Got it.
Okay. So that's why we need the grid like
Yeah.
thing.
Yeah.
Okay.
If
Then
you
could
don't
you
have
explain
the
the
grid,
yes,
yeah, if you don't have the grid like thing, right, then you have to again go through the all, I mean, whatever the points
all the
are.
points?
Yeah.
Okay. Now could you explain the grid calculation?
Yeah.
Till now this is clear.
Okay.
Yes. Yes. This thing.
Okay. What you are doing, right? Now you are comparing each point with every other point. So you are searching for any point within this grid. If it not your limit, if there is a point here, then you are searching for every other grids, whatever the distance between those points.
Okay, here I have a specific doubt that suppose one point, can you mark one point?
Yeah. Yeah, sure.
Yes, suppose this point, then what will be the boundary? I mean, where we compare other points?
Okay. Okay, let's say this point.
For this
Let's say,
one point.
yeah, for this point, you can take up to this grid on this part of the grid. Even if you are not comfortable, you can take one more grid. That's for just for sake. But that is totally, if you come into delta, one grid is enough. 16 is just for a safety, even though.
Okay, each grid length is delta by 2, so we will compute delta.
Yeah, if you take
In
the
both.
max distance of delta, that's enough.
Okay.
Yeah, even though we are splitting into delta by 2, that's fine.
Okay, and one thing I cannot recall clearly that Professor Madhavan marked 16 points, and these are on the each cross section, right? One point in each cross section.
Yeah.
So what is that concept?
Okay, that is the maximum, this each point against 16, 15 others. Okay, let's say every that grid, right? If you fix some grid, you have to search point whatever point, what is the distance between, if some point is here, you're searching between each of the grid.
Yes.
Okay.
Yes.
If you do it for all the cells, okay, that value is a fixed value which is constant.
Okay.
Okay.
That's
Yeah.
it is 16 comparison.
Yeah. Okay. You did this one. Okay. Then you moved your grid to the next level. Then you are doing the search on second. You moved that whatever the region of your focus. Then again, whatever it is a constant value.
Yes, constant number of comparison.
Yeah. If it comes to the asymptotic complexity, right? That won't be totally, we can neglect those because of the
Yes.
because it is a constant.
Yes. Now it's clear, sir.
Yeah, I mean,
thank you, sir. Thank you.
yeah, even though you can watch that lecture one more, even though sir, I mean, gave more subtle concept in the lecture.
Yes. I will watch it one more.
Yeah. Yes, sir. Please.
So, am I audible?
Yes, sir. Yes, you are audible.
Okay. So rather than creating the boxes or bins, if we just take our current y value of our point and just add the delta to it and select of whatever other points are in the opposite region, which fall into the same range, like from my current y point to plus delta y plus delta points. Since it is already sorted, we can see it directly.
Yeah.
Rather than creating bins, we can do that also.
Yeah, but in that case, right? That one, it is based on number of points there. Whatever the algorithm you're doing, right? That is based on the points. I mean, let's say if there are many points within the grid, I mean, let's say the same thing. You assume there is no grid, then your algorithm is based on the number of points. If in the same region there are multiple points, your algorithm will be based on the number of points there in the region that you have to account for. But in the grid form, you don't need to. It is fixed. Yeah, whatever you say, what you said, it will work. You have to collect the each points here first of all, then do the operation. Okay, let's say you are fixing some region, some y, which is y plus delta to y minus delta, and you have to filter out what are the points are within this region. Then you have to brute forcefully compare every points with each other.
So,
What
but
you
it is already sorted.
Yeah.
The points are already sorted according to the y coordinate. We can just use it.
Okay. Yeah. Same thing. It is sorted based on y coordinate, but you never know, right? Let's say. Okay. The same example I gave. You say it is the nearest point based on y coordinate, but there could be another coordinate which is just like that, which is much nearer to the x coordinate. So we need both x and y. Simply sorted based on y coordinate is not enough.
Okay, sir, I got it.
Yeah.
There can be another point which is closer, which is in that region, in that y region, but its x coordinate may be very far away.
Yeah.
So we need both horizontal and vertical separations.
Yeah.
So that's why we need to sort according to x and y both.
Yes. Yeah, when it come to this kind of dimension, unless there is a fact we can reduce into a single dimension, we have to do the based on both two-dimensional data we need. If it's a three-dimensional quantity, right, then it will be we surely need x, y, and z. Yeah, then this part which is a region here, then it will become a cuboid kind of block. If it's a 3D.
Yes, sir. Now, sir, I also have doubt in the recursion tree concept. Could you explain that?
Yeah.
I mean, suppose we know the splitting that we know the splitting of sub problems, and now how can I find the I mean T of n?
Okay. In this lecture, right?
Yes, sir. Yes, sir.
Okay. Can you specify where?
So the picture.
Okay,
Yes,
there is
this
summary
picture.
which is the. Okay.
You take just one example and explain it, then other I can understand.
Yeah. You understood this? What is mean by R? What is mean by C and F? Right?
No, sir. Can you repeat that?
Okay.
Yes,
Okay.
I understood. No, but not clearly. Yes, this portion, sir.
Okay. Okay. Yeah, I get it. First of all, during that recursion, right, you have to know whether this thing is growing or shrinking or the same.
Okay.
Okay.
Okay. So in
At
binary
any
search,
level. Yeah.
okay, in binary search that is shrinking, and what is the example of growing?
Growing, yeah. Okay. A factorial.
Okay, okay. Factorial it is growing.
Yeah.
And, am I right that binary search is shrinking?
Even in the binary search, right? That will be almost a constant. Okay. It will be almost equal only.
Okay, equal. Okay, so how can I differentiate that it is growing or shrinking?
Okay. Father, just calculate this series. Okay. If it is calculate this series, then if it's a decreasing series, then the order is based on the function.
Order is based on the function. Okay, could you explain the whole concept?
Okay. Yeah. Just
I mean, from the picture, starting from the picture slide.
Okay. I'll just explain what are those. Okay. You know that whenever we write that function, there is a based on the inductor relationship, recurrence relationship, right? Something
Yes.
based on the, it is splitted or whatever doing that, plus some function we are doing here.
Okay, it's R into T of n by C. Okay.
Yeah. If it's a binary tree, right, it will be like a n by 2 plus
And
1.
the R is 1.
Yeah, 1, because we are calculating the middle index. It's based on some order 1. If it's a if it's a merge sort, it will be order of n.
Okay, order of n.
Yeah, this order of n comes from the merging part.
Merging part, okay.
Okay. So our entire recurrence relation we can figure out based on this thing. I mean, how many times we are solving those problems. That is the R for. I mean, this is a number of recurrence path which is splitted into f of n is the time spent on the recursive work, non-recursive work.
Non-recursive work, yes.
Yeah. And n by c is the splitting partition. And c is the denominator. I mean, how many times it got split.
Yes, yes.
If you do that,
yes, this is okay.
Yeah. In binary search, right, it will be simply we are searching in one R will be 1, f of n will be 1.
Okay, and C will be 2.
Yeah, C will be 2. Yeah, it will be divided into half. If you count through the series, then you will get this. Also, I explained how in discourse as well, how binary search will comes to this log n.
Okay, and there is one more thing that in binary search, merge sort, these are the n by c is same for two sub problems, and sometimes there are different, like 2n by n by 3 and 2n by 3, such kind of thing. And how can I compute this?
Okay. The binary search and merge sort, right? If both are equal, but if the function of n times log n, right? In binary search, the f of n becomes 1. So it will be simply log n. In merge sort, it will be order of n, so n log n.
Okay, so we need to calculate this series, right?
Yes,
Tn.
yeah.
Okay. So Tn equals O of f of n. Okay. Can you, I mean, take an example and calculate this?
Yeah. Even we can, here it's one also. Yeah, Sir gave one example. Yeah. It is a merge sort, right?
Yes. Can you explain this?
Okay. If you compute that series, it will be the exam exactly the same. Okay.
Hello.
Yeah, I'll do that. Just 1 minute. I will share the whole screen.
And sir, take any two problem, one from the splitting, when splitting is similar, same, and when splitting is different. So then it will be better.
Yeah. Okay, it is the sequence. Okay, for METSA, we are splitting into two parts, right? Whenever that two will split into two, again two.
Uh,
So that R will be 2. That also C will be 2. F of
so
n will
what
be
is the
n.
okay? So what is the four? I mean, there are four branches, right, from n.
Yeah. I don't think
So
that is for that another thing. That integer multiplication thing. Have you seen that? That in on video on lecture on based on that.
yes, integer. I watch
This
it.
figure is for that. That is the growing series.
Okay. And that is for
For 3
integer
example.
multiplication. Yes.
Yeah, it is the METSA. It will split into 2. That will split into 2. Based on that, if you calculate that series, right, that will be order of some n. What is the caution? Say that order of n cost will be it will be 1 times that. In the first one it will be n, it will be 2. That order of n will be n by 2 for each, right? I mean, if it's split into 2, that cost of each each iteration will be n by 2, so it will be again 2, so it will be plus 1. Okay, it will be exactly. Also next it will be n by 4, this n by 2.
Okay.
You get it, right? I mean, it's n.
Yes.
Yeah, it's n. So the series will be same.
Okay, sir.
Okay. If you go to the, if it's a series is equal, then you have to apply this rule. F of n, order of f of n times log n. F of n is
Okay, so
simply n, so simply log n.
okay, so how could I get the log n?
Log n is it is default. It is what we computed, but to the base is what you are taken is the base. That's it, totally up to you. Whatever the base you are taking, that will apply. It will work.
Okay, this will be log n, but the base will be base will be based on how many split.
Yeah, splitting.
How many branches? How many branches are there?
Yeah.
Okay.
Base to the C. Generally.
Okay. And can you example one thing that is when series is not similar, like n, this is n plus n plus n dot, right?
Yeah.
So when this is different.
Okay. Have you seen that? If you see the integer multiplication video, right? That
Yes,
will be different.
yes, I watch it.
Yeah. Okay. I'll simply explain this example itself. Okay. For each time, there will be 4 multiplication.
Yes,
If you split into 2, there will be like a that 2, okay, the 4 will be like okay, x naught y naught plus another one is x naught y1 x1 y naught x1 y1, which these two belongs to 2 power n, I mean the full bit thing, but others are half bits, n by 2 times bit, and others are simply constants, right? So each time it will be splitted into 4.
Yes.
But if you calculate the sum of it, it will, this first is n, let's say series, then it will be 2n, it will be like 4n. So the series is expanding.
Yes. Yes.
The series is expanding, right? So
Yes.
for the expanding series, just apply the formula. Just go through the rule. It will be based on the order of n power log c of n. Okay, so here the splitting is,
And sir, is there any method without computing the series or something?
yeah, it is the simplest method. One more method is unraveling, what you learned in week 2. Yeah.
Yes, that is little difficult.
Yeah, it
Right.
is much easier.
First-
Yeah, that is the standard step-by-step unravel procedure.
Okay, so I have to calculate the series.
Yes.
Okay. And can you calculate that from the series? How can I get O of n power log c base r?
Yeah, that is a standard thing. I mean, if it's a increasing series, right? Then it
Okay,
will be
I'm
based on the
asking
order.
because like I'm asking because suppose there is a problem and I got the picture kind of thing, like how many branches are there, then I have to compute the complexity, right?
Yeah.
So that's why I'm asking that. If yes, if I know this picture, then how can I get to the n to the power log c base r?
Okay. First of all, if you know that if something is expanding, the work is getting increased and increased. Okay.
Increased on?
Increased and increased. I mean, if you come into a second recursion level, each recursion level that effort, I mean, whatever the computation you are doing, right, which is increased than the previous recursive level.
Yes.
Okay, then definitely you can say it is based on some, it is surely not order of n. N
Okay,
to the
so
some
this is
exponent or exponential solution.
okay. N to the power, this is increased like n to the power something, like first is n, then 2n, then 4n.
Yeah, either it should be a polynomial solution or exponential solution.
Yes.
Okay.
Okay.
Yeah, then that's the one thing you can definitely sure about. For the exact amount, you have to use the formula. You have to use the series and compute those.
Okay, and can you explain the there is one like n by 3 and 2n by 3, such kind of thing? The quick sort example, can you explain it?
Yeah, sure. For quick sort, right? Are you clear with this one?
Yes, I clear with this one. I have to compute the series.
Yeah, you have to
Right.
compute. Yeah, I mean, if you visualize this also, it also works, but better you go compute the series. That works.
Okay. Yes, this thing here we do not have same kind of thing, right?
Yeah.
in both branch branch, I mean in each node the value is different.
Yeah.
So how can I put the two R value and C value?
Okay. That is the thing. At the depth, right? At 3/2, it will become order of log n. I mean the maximum one. I mean, if you go to the depth, right, that is a logarithmic solution.
Okay, but to put this in the formula, I have to know the R value and C value, right? So what will be the R value and C value here?
Okay.
So C value, I think it is 2,
Okay.
right?
Yeah, C value is here. It is 3, 2/3, and okay, I get it. Yeah. Yeah, you can take the maximum one at least. For the max value, you can take that, but yeah, we'll try that. Okay, how sad it is. If you go to the log level, right, that will be totally based on log of n, order of log of n.
Yes, order of log of n.
Yeah. Then then either you can calculate individually for each series, that R will be split into multiple things and sum it up. Okay, I'll just try it. That R is not a fixed value for here. That is sure.
Okay, and I cannot recall that. Can you say that what was R? C was the splitting, right? Number of splitting.
Yeah.
And what was the R?
R is also not a constant. It is not a constant. Even C is not a constant here. Okay.
Yes.
Okay, I'll try it. I don't know the answer exactly now. Just I'll try it out. Even just like a merge sort or like here, it is not. It is unequal partition. R is 2, which is number of the division which we are doing. It's based on number of recursive calls, so R is definitely 2.
Yes. R is 2.
Yeah, C is okay. That's recursive calls. So, one is 1/3. Another one is 2/3.
What was the C?
C is the division.
Okay, division. Okay, so here we can take the maximum thing, right? Because we can take the C equal 2/3, then it will be O of, I mean, worst case complexity.
Yeah. One more thing is, if we do the division by this much, something will go on, like something will produce holes as well. Holes in the sense, I mean, in some case, right, there will be a value here, there won't be a value here. That also occurs.
Okay.
That's why how the depth is calculated here.
Yes, there may be holes like, but if we take c equal 2/3, then it can compute the worst case complexity, right?
Yeah.
And what will be the value of f of n?
Okay, let's say.
I mean the non-recursive steps.
No, that's n. Order of n. That will be 9. We are doing that merging, right?
Okay, so if I put these three values in the formula, in the series formula, then I can find the complexity.
Yeah.
Right. Okay.
Yeah. It will be order of n by 3. Then for this one, this thing, right? It will be order of 2n by 3. It will be order of n by 9 to n by 9. It goes on. So n. Okay.
But here, if we, sir, if we do not take the n by 3 and 2n by 3 in both case and take only 2n by 3, then will it be correct?
No. We should not. I mean, that would be a total series, right?
Okay.
Okay. Okay. Here we missed out some parts. Here, these things also considered, right? 2n by 9 plus 4n by 9. The entire thing. Yeah. And plus it will be 2. No, not sure. Okay, actually, I'm not sure about this. Please ask this question on Discourse, and I'll answer there. Yeah, I'll do
Okay,
some.
sir. Okay. Yes, sir. I will post in Discourse it.
Yeah, because actually, Sir used some technique, but I even forgot that.
Yes, I asked this because there are a few problems in practice and graded questions also, that they give the problem statement, how
Yeah,
to
I
branch
know.
it, and I have to compute, and I'm not able to solve such problems. So that's why I'm asking for this concept.
Okay. Okay. Anything else?
Uh, Okay, can you discuss the practice assignment 8, the last question? So that will be better.
Okay. Mm.
Is this last one?
Okay. It is based on that relation, right? That a median will locate between n by 7 to 6 n by 7 in this range.
Yes.
Yeah, that's based on that only.
Which of the following? Okay, so n by 7 to 6,
Yeah,
n by
definitely.
7.
Yeah. If you, it's just logically, if you say 0 and n, right? Whatever the numbers, it is n by 7. It is 6 n by 7. Simply, okay. Whenever you the median will always located in between in this region. Surely, if you know
Yes.
that, yeah, you can answer this question.
Okay, so here,
The second option says this region. Okay, the
yes.
final option says this region. So this two.
So here also the R and C formula works, right?
Possible. Yeah, but you have to, yeah, you can try that.
Yes. So I can see here that C is
Yeah, but the
7
orange formula works. It also gives the n log n mark because
in log n.
yeah.
So yes, how can you say that it is n log n?
Okay, definitely you can say the splitting is based on one, right? We are not multiple splitting. Yes,
Splitting is based
and yeah, whenever we part, if you say binary, simple, first of all, binary search, we are not searching if it's a value which is less than here, it is a focus region. We are never go into this region. Similarly,
yes.
yeah, we know the median. So it is less than median or right side of median. So never we surely will go through this region. That order of n part will constitutes the that merging or whatever that thing. So this splitting will always go for log n times. Some logarithmic values.
Okay. Because okay. So
Yeah,
R is one here.
Yeah.
R
R
value is 1 here.
also, whenever this splitting, it will again split into 2, but you can be sure that in some logarithmic value, it will end. So that process
Yes.
will be log of times. Then order of n will be on each iteration, so it will be n log. I mean, it's the simplest thing, but you can go through the whatever Rn thing as well.
Okay, and one more thing, and can you explain the fast select? There is a problem like choosing the median, right?
Yeah.
So can you explain that? Yes, this concept.
Okay. You want to choose how to find the median of median, right? Or
Yes.
something else? Okay. We are dividing into 5 blocks. Whatever the list we are splitting into 5 blocks. If it's less than 5,
The entire in numbers.
yes. If the length of the list is less than 5, then it will be, we are doing by brute force. We simply doing a brute force search and giving the whatever the median we have.
Yes.
Also, one more thing we have to show here, it is a length of L, not simplify, because sometimes the value will be which no need to be exactly the multiple of 5, right? It should be 2 or 3.
Okay.
So in one case, if it's less than 5, we are doing brute force. If it's greater than 5, what we are doing is we are splitting into multiple blocks, and we are making a median out of it.
Okay, for each block we need to find out the median.
Yes. For that, what we are doing is we are creating simply a list of medians.
Okay, list of medians.
Yeah.
So yes, so suppose there are 100 numbers.
Okay.
So we are doing five blocks. So there are 20 media, blocks, right?
Yeah.
Okay, and we find 20 medians. Is it?
Yeah, yeah, exactly.
So now
Yeah, initially it
20.
will be 100. So again, among the 100, it is already sorted, right? I mean, so not already sorted. Within the first five, it is sort and we find the median. Second phase part and find the median.
Yes, yes.
And
So here
after some time,
here is
here or not, we are combining if we get the five values, let's say simply assume there is five, then we are finding the median out of it. One median out of it.
okay.
Simply
Here I
proceed.
have two doubts.
Yeah.
One is for each block, I have to assume that the block is, I mean, the five block, right?
Yeah.
The five element block.
Yeah.
So I have to assume that the block is sorted, or I have to sort by brute force it, and then I find the median of each
Yeah,
block.
that five block is that smaller five block, right? There you are brute forcefully sorting it out.
Okay, I have to sort each
Five block
block.
by brute force. Yeah, because
Brute force.
it's a constant number, right? If five is not a big number,
Yes.
also you don't need to go through that much level also. So it's totally a
Yes.
constant value. We can neglect this.
Okay. Then in the next level, I will get 20 medians.
Yeah.
Then what I will do with these 20 medians? That is second.
Again, find the median of that median.
In the same approach.
Yeah, same
Right.
approach. Yeah, if you get the 100, then you get the 20, then you will get 4.
And then
Among
four.
the 4, find the median of what is the median
Okay.
of 4.
Okay. Okay. Now it's clear, sir. Thank you.
Okay. Okay. Anything else? Others?
Oh, sir, I have one more doubt. Can you scroll up the page? Sorry, scroll down. Yes, one more. Yes, sir. This thing. That how can I discard that left top and right bottom part? I mean, what is the logic behind it? That we are discarding, na?
Okay. Okay, you understand this one, right?
Yes, yes.
Okay. It's not like, okay. Okay, I think that it is not even, I'm not sure, but I'll get it and
Okay,
get
sir.
back to you.
Can I post it on Discord?
Yeah, yeah, sure, sure. Yeah, no.
Okay.
I'm not sure
Okay, sir.
whether
Thank
we are
you.
discarding or later. Yeah, just I'll get back to you later. Yeah.
Okay, sir. I will post it on Discord.
Yeah.
Okay.
Yes, Jagar.
Sir, I have a conceptual doubt.
Yeah.
I was watching the lecture of quick median, and
Sorry,
in that,
which one?
divide and conquer quick median.
Okay.
So in that algorithm, sir said that to find the kth largest element. So
Yeah.
what does it mean? It means from the largest side, like first largest, second largest.
Yes,
First
exactly.
largest will be the largest element.
Yeah.
In that way, or from the
Yeah, it's
your,
exactly what you said. I mean, let's say.
okay. So sir,
I mean,
how
the
does
kth largest is right.
okay.
Yeah, and then first will be the 5, then 4, 3, like that.
Okay. So in that algorithm, sir said that if the length of the lower element is less than k, when we select the pivot and we arrange them in lower and upper part,
Yeah.
then if the length of the lower side is less than k, we say that the kth largest element in that region. That I didn't understand. How?
Yeah, okay. We are splitting in some way, right? I mean, let's say whatever the things which is on either side, which is sorted, which is already sorted when it comes to the when it comes to after the recursive, right? Suppose
Yes.
you are finding the second largest element here. Okay, I'm counting from one. Let's say second largest element. Then I'm searching for in the highest part because I'm searching for the highest one. Then the length of the element, this part is, let's say 2, then definitely the second largest was here only.
Yes, but sir was saying to see in the lower part. If the length of the lower part is less than m, less than k.
Okay. Here we are finding the kth largest element.
Okay, so leave it. If you can just explain the
Yeah.
algorithm, that will be the great help.
Yeah, it will be exactly like the Pixar. Like, whatever doing here, right? Which we already whatever instead of simply sorting, we are finding that element. First of all, the use of quick select is finding the kth largest or kth smallest. That's it. If you want to find some, let's say, 100 element, you want to find the 55th largest element. Then you have to do the maximum. If it's a naive way, you have to go through the order of n 55 times. The simple search will take 55 times, but it will give, but quick select will give you in a log n time, n log n time, average case. That's a first requirement why what is the use of quick select. Okay. 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 How it works, right? How Sarah said it is on lower part is whenever we do the recursive call here, right? We are decreasing that value of k by 1. That's why the answer lies in lower part. Okay, I'll explain. If it's a k, if it's 0, or these are the base condition. or if the case goes k goes behind the whatever the boundary required, we are simply returning. We are taking the pivot as first element, okay, and lower and upper region.
So your pointer is not visible.
Okay. Okay, I'll reshare things. Is it visible now?
Yes, sir.
Okay. This region is totally the Quickselect region, right? We are going through the each region, and if the pivot is like if the value is greater than pivot, we are increasing the upper pointer by one time, by one. The value of the upper will goes +1, or else if it's less than, we'll exchange the value and increase both lower and upper. It will be much better on the quick sort, but if you know the quick sort, it will be the exact same thing. After this thing, we are changing the, we will move the pivot to the respective position.
Sir, I understood quick sort. Just here, what the key thing is that what we are doing with the k. If it is in the upper, we are doing k minus lower length +1.
Okay, sorry, but I'll get back to you on discourse. Okay, I'm sorry, but I'll just ask it on discourse. I'll get back to you there.
Can I explain this one, sir?
Yeah, sure, please.
So the question is why we are updating the value of k to k minus lower length +1, right?
Yeah.
Okay. After one run of the code that is above, the pivot is placed in its right place. Suppose the pivot is placed on in the fifth. The pivot is the fifth element. What that necessarily means is there are 4 elements which is smaller than the pivot. Okay.
Yeah.
And if the number, if we are searching for a number which is larger than the pivot's position, which is, let's say we are searching for the 7th largest element. Okay. So since the first 4 elements are smaller than the pivot and the pivot is the 5th smallest element, pivot will always be in its, pivot will be in its right place after the quick sort has run. So the pivot is the 5th largest element. So when we are only taking the right half, right half of the list, the right side of the pivot, then we are discarding the 5 elements, 4 elements and the pivot itself. That's why now our job is not to find the 7th largest element, but the 2nd largest element, since we are discarding the pivot and the 4th element. That's why we are updating the value. K was 7, lower lane was 4, lower lane +1 is 5, 7 minus 5 is 2. That's how it works. Is this clear?
Yeah, got it. Yeah. Have you understood?
Yes, sir. Yes, sir.
Yeah. Okay. Anything else?
Santana sir, I had a question.
Yeah.
I just joined, so I don't know whether this has been discussed earlier or not.
Okay.
There was a question that we want to. There was a question in quiz 2. Can we discuss it here?
Oh yeah, sure. What is the question?
The question was that we want to support and the next smaller element in a heap.
Oh, sorry,
The input will
lost
be
you
an,
in between. Yeah, just can you repeat what you
Okay.
said last time? Yeah.
the question is that suppose we want to support the operation of finding the next larger element of V. V is an element in the heap.
Okay.
The element will be given to us. We want to find the next larger or next smaller element. And what the question was, what is the time complexity of finding the next larger or next smaller element?
Okay.
Apologies for the background noise.
Okay.
So, what is the time complexity of this operation? I think the answer key is the answer says that it's linear. O of n. Can you kindly explain this?
Yeah. Okay. Is the question provided here?
The question was from quiz 2, sir.
Yes.
Yes, yes.
Okay. Which set, you know?
I think it's from C. Yeah. You just passed it. Yes. Yeah, no.
This question you're saying, or
No, not this one. I think it will be. I think it's D, sir. I'm sorry. Can you go back to the other question, sir? I always confuse this. Yes, this one. I mean this question set.
okay.
Let me just check for myself and get back to you.
Okay. You want this question?
Oh, this one. Yeah, this one. Exactly this one.
Okay. Here the thing is, it involves searching. I mean, you know, right? Searching takes order of n time in log heap, right? You are not. You are not. Let's say
after I find the element, after I find the element, it's a fixed amount of work. So I have to just see how much time I need to find the element.
Yes.
And in heap, finding an element by value is order of n.
Yes. But if it's a binary search tree, you can say you can easily navigate those things.
It's log n. Yes.
Yeah.
Okay. So that is the only operation that takes linear time in heap, and all the other operations are log n, I suppose.
Yes. Also, that constructing a heap also order of log n.
Yes. Constructing a heap of n elements takes linear time. That I understand, sir.
Yeah.
Okay, I was confused with this one. Thanks, sir.
Okay. Okay. Others, any doubt?
No, sir, no that in particular, but I will try to implement this in code. If I have any problem, I can post it in Discourse.
Sorry, which algorithm you want to?
This divide and conquer algorithm, all the fours. like quick finding the median and
yeah,
process per.
yeah, some of them was already provided. Yeah, you can do that. Also, you can try this question as well.
So what is happening that I am implementing it, but it's taking more time than n square. If I compare it to the time module, it is taking more time.
Have you tested with a very large test case?
Yes, sir. I have used 10 to the power 6 number of elements.
Okay. Yeah, but that,
Randomly generated.
okay, that won't be the case, but generally, but if it's a small test case, that recursive call will take more time. That I agree. Okay, but that I'm not sure. You can, yeah, you can post it on Discourse and let others also know.
Okay, sir. So is there a way of implementing it non-recursively?
Non-recursively, yeah, you can do that, but that won't be not as a straightforward. Then either you have to build a stack and put it over there and solve using a while loop. Take it from one element in each thing in a while loop. Yeah, if you
Okay,
use, if you are using recursion, that is which is a very straightforward one. Okay, others, anything? Just one more time. Do you have any feedback on quiz 2? How was it, and are you satisfied, or just like that? Anything on quiz 2 feedback? Okay.
so all questions were okay in case 2, but from the heap part, I was facing difficulty in solving them.
Oh, okay.
Like what mentioned, like Sandeep mentioned that question, I
Yeah.
also made that question wrong.
Okay. Yeah, that's a tricky one. Yeah.
If we can have a revision for implementation of heap, it will be better
Okay.
because we have only theory in that lectures.
Yeah. You want the programming part, right?
Yes, sir.
Okay. Yeah. I agree. I'll ask for others as well. But in the end term, it will be based on the whatever the objective type only. So that's why there is nothing more on the programming part. Yeah. Okay. Yeah, I'll pass it to the respective person.
Because after implementing the codes only, we have a better grasp of the concept.
Yeah, but you can do that by yourself, right?
Okay, thank you, sir.
Yeah. Also, you can cross verify with the default heap package, which is available in Python itself. I think it is called heap q, I think. Yeah. It will convert your existing list into sorted based on the heap form. In a min heap form.
Which package, sir?
Its name was heap q, I believe.
Okay.
if you can use this to use the existing list into a heap form. I mean, there won't be a new objective data type or like that. You can pass your list, it will reorder the list according to the heap order. Then you can do all the insert and delete operation using it as well. Also, you can try your own as well. That's also easy. That's not a big thing. The construction of heap. That heapify code, I think Sir also used in the lectures as well.
It was in programming assignments,
Yeah.
but they were a bit high level.
Okay. Yeah, you can either you can try it on and work on. I mean, yeah, work around it. You'll get to know. I mean, heap queue is just one way you can verify those whatever the values are correct if it's a very large input or like that.
I think there is a good explanation of Heapify and Max building a heap given by Ankur Parmar during the revision session for quiz 2.
Okay.
But there is a but there is a limitation to that. I think we have only used integer values. When you take a list and convert it to a heap, we are necessarily working with only integer values. But I want to know how to implement this by object-oriented programming. I think each element would be will be an object.
Okay.
So that will have a value and that will have 2 pointers. I think that's a more robust way of implementing the heap.
Yeah, I agree, but it is the simplest way. That's I mean, whatever you said, right? It is much similar to the whatever the binary search tree or like that. The binary search tree implementation SAR did, right? That's the way you want.
Yeah, yes.
There is a simpler way here. That's why that object oriented way was not introduced here. That's the only thing.
Okay.
You can try it out. Okay. Anything else? Or else we'll wind up the session. Okay. If some question which I haven't answered this question, just post it on Discourse and tag me in it. I will answer it as soon as possible. Thank you all. Yeah. Bye.